Even though we have graphical user interface programs to use expeyes, it's not really necessary to have them. If you know how to write programs in Python programming language, you can communicate to expeyes hardware. Let's have a look at the internals. This is the basic design of expeyes. So you have user programs written in Python, like all our GUI programs are of this category. And then we have some libraries or Python modules. There is something called icej.py that has all the communication programs, and it is written in C language also, so that people can write applications in C. Now here it communicates to the USB link, and inside the expeyes box we have a microcontroller running, and there is another C program running here. So if you know how to do this communication, then it is possible to use expeyes. First of all, let us start the Python interpreter. Type Python. Now you are inside the Python interpreter. So to use this, we need to import the library, that is expeyes.icj. After importing this library, we have to now open the hardware. So we have to search for the hardware and establish as a connection. So now we are going to search for the hardware, and if this comes like this, that means it has found, otherwise an error message will come. Now if you want to know about this, all the functions, you can say help of expeyes.icj. It will list all the functions available and give a brief description of this whole module. So we will not go into details of that. Let us do a simple setup, say p.set voltage to say 2 volts, and all these details you can get from the programmer's manual. So let's say p is 2 volts, and we are using a connection something like this. That means the programmable voltage source is connected to in2. So whatever voltage we set here, it should appear in in2. And if you look at in2, see in2 has a channel number of 4 here. You can see it's 4. In1 is 3. See A1 is having a channel number of 1. A2 is having a channel number of 2. So these channel numbers are used for programming it. That is how I identify different terminals. So I can say here, say p dot get voltage, get underscore voltage of channel 4. You can see you are getting the same voltage back. Now to verify that, you can change it to another voltage, is 2.5, and get again. So you are getting same. And if you want to see the AC, and we know that in our connection here the AC output is connected to A1. So if you do the get voltage on A1, every time we should get different values. See, it is changing. So how do we capture a waveform? We can say p dot capture, again give the channel number 1. Then the question is how many points you want to capture. Let us say we'll capture something like 400. The maximum value is 1800. That's the limitation by the memory of the microcontroller. And now the next question is, when you read this 400 points, 400 times you are going to measure the voltage, what should be the time interval between subsequent digitizations? Let us take that as a 50 microseconds, because it is only 150 Hz signal. The minimum value you can give here is 4, and we will give say 50 because it's a low frequency signal. Now you will get a 400 data points, so a huge list will come, so you will not be able to understand anything. So but let us take only say 4 of them so that we can understand the data. You can see the output which is coming has 4, there are 2 vectors. This is the time. You can see that time is 0, then after 50 microseconds, after 100 microseconds, then after 150 microseconds, and these are the voltage values obtained. But seeing like this doesn't make much sense. So we need to get large number of points, but once you get large number of points, you should be able to plot it. So we'll use a program called pylab. Say from pylab, that is a matplotlib library, say import everything, import star. Now we'll again call this capture with 400 points, and the values you can see here, there are 2, time vector and the voltage vector, so assign it to T and V. So now our T and V has the time and voltage coordinates. Simply say plot T and V, and before that probably you can put the matplotlib in the interactive mode on, then say plot T and V. The plot window, okay, you can see here this is the plot. So that means capturing and plotting a waveform in this manner is only matter of writing couple of lines of code. Now if you want to capture at a higher resolution, you can use something called capture underscore HR and plot it again. So it is, the plot is going on again on the same one, but you can see here the kinks and all absent in the second one. So it's high resolution captures with the 12-bit resolution, the one is 8-bit. Now suppose say if I want to capture the sound that is connected to, you can see here our microphone output is connected to A2. So how do we get that? Like if I want to capture the signal, all I have to do is say capture, instead of channel 1 say channel 2, but here I should not put 2, this 50, I should put probably say 5 or something, because it is going to be a higher frequency signal, so you should sample it closely. The time between 2 measurements would be shorter. Let's get that and plot it again. You can see there is only a small line here and there is no signal there, so we will close this. And how to get some signal there, that is the issue. For that we need to send something to this, like we have to energize this square one and apply a square, generate a square wave here. That can be easily done here. P dot set square one, say let us put it as 3800 hertz. Now we will capture channel 2 and plot it. You can see here, you are seeing that microphone output. If you want to put off the waveform, you enter 0. Now the square one output goes to 5 volt, but square one output is occasionally used for driving LEDs. So now it is permanently set to 5 volts. If you want to put it off, there is an option, you set it to -1. Now the square one output is 0. How do you verify that? You suppose say you set it to -1. Now it is low, right? If you look at the picture here again on the top panel, you can see square one output is 8, but the input readback is channel is 6. So we can give a get voltage on 6. So we will see get voltage on 6, it is 0. Now set the square one to 0 That means it should have gone to 5 volt. Now you can see it has gone very close to 5 volts. It's only 2 millivolts error. That is your USB supply voltage. So this is how you can control square 1, and you can as well control square 2 this way. Now other things which we have connected is our LDR is sitting here from this point, send, that is channel number 5. So we can see what is the voltage across the LDR. So what you say is P dot get voltage is 5, and that is 1.44 volts. Now I am covering the LED, this LDR, with my hand and making another measurement. It almost goes to 5 volts. That means the resistance, almost all the voltage is getting dropped across this one. And if you again allow it to the light and make a measurement, it is low. If you put some very bright light, it will go to very low value, because the resistance compared to that 5.1k, it is going very small. Now to measure the capacitance which is connected to this point, all we have to do is say P dot measure underscore cap. So it says it gives value now. But remember, this one is not subtracting that socket capacitance. So you have to now remove the capacitor and make another measurement. Like if you are using the command line, now I remove the capacitor and make another measurement. Now from this value has to be subtracted. Now similarly, the LDR, that resistance value, if you can directly, if you want to print, you can say it is measure res. It is giving around 2.1k. Now I will cover the resistor and measure again. It gives bigger value. Leave it again open, measure again, get another value.